Hello all, welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, write a Java program to demonstrate bubble sort algorithm. Let me answer this question with practical demonstration. Before I practically demonstrate what exactly is the Java program that we have to write for demonstrating a bubble sort algorithm, let's first understand what is this bubble sort algorithm. Okay, what does it do? With an example, I'll show you guys. After that, I'll explain the theoretical part. Then I'll go for the practical demonstration. Okay, so step by step, we'll learn about the bubble sort algorithm. So here you have, let's say here you have some numbers. Okay, let's say there are some numbers here. Let's say 3, 12, 2, 9, 7, 8, 5, 4, 15, 26, 22, 18. Like that, some numbers are there. Assume that. Okay. Then what happens here is, in case of bubble sort algorithm, whatever I'm covering is a bubble sort algorithm. How does it work? You have to understand first. Bubble sort algorithm. Okay. Bubble sort algorithm. So as part of this bubble sort algorithm, okay, what we can do is we'll compare the first number with the second number. The first number is greater than the second number, then we are going to swap these numbers. As you can clearly see that, 3 and 12. Okay, 3 and 12. 3 is less than 12. So no issues. Now you will compare the next one, 12 and 2. Next one is 12 and 2 you will compare. Okay, 12 when you compare with 2, you can clearly say that 2 is, okay, less than 12. So 12 will come here. Fine. Now the next thing is, after 3 and 12 got compared, 3 was here only, 12 went there. Now 12 you are comparing, okay, 2 and 12. Here 12 and 9 you are comparing. 12 and 9. 9 is less. So here 9 and 12 will happen. Now, okay, 9, 12 happened. Now 12 came here, 9 came here. Okay, now 12 and 7 will be compared. So 7 will come here and 12 will go here. Okay, then after that, 12 and 8 will be compared. So 8 will be compared with the 12 and 12 will come here somehow. Okay, now 12 and 5 will be compared. So 5 will come here and 12 will go here. Then 12 and 4 will be compared. 4 will come here and 12 will go here. Okay, then 12 and 15 will be compared. Okay, 12 and 15, in that 15 is the largest, right? So they will not be swapped. Now 15 and 26 will be compared. 15 and 26 will be compared. Okay, since 15 is less than 26, it will not change anything. So here 26 will happen. Okay, then 26, let's say. Now 26 and 22 will be compared. 22 is less than 26. 22 is less than 26. So 22 and 26. Now 26 and 18 will be compared. 18 will come here and 26 will go here. So finally, the largest number of all these values will go to the ending. Okay, bubble sort. You see, when you, let's say there is a water bottle having a bubble inside that, if you turn upside down or whatever, you can see a bubble moving out up, right? So the biggest number here is nothing but the largest number out of all these numbers during the swapping process from the first number to the last number. Whatever the largest number will result in the end. Okay, so now what happens next is that the story is not ended, guys. Okay, you will ignore the last number. This is like a bubble which has come to the top. By ignoring that bubble, remaining all elements, again you have to perform the same swapping operation. That means, for assume that this is a resultant of the first swapping iteration. Next iteration, what you will do is, you will not consider about the 26. Remaining all till 18, you will try to the comparison. 3 and 2. Okay, 3 and 2 if you write, just understand here what is happening. 2 will come here and 3, because 3 is greater than means Okay, definitely 3 will go to the next level. 3 will be compared with 9 and 3 is less than 9, so no issues. 3 less than 9 and 9 and 7, if you see, 7 has to come here because 7 is the least and 9 is the greatest, 9 will go here. 9 and 8, 8 will come here, 8 will come here and 9 will go here. Okay, because 9 is greatest. 9 and 5, 5 will come here and 9 will go here. Okay, then 9, 4, 4 is this, so 4 and 9 will be swapped. Then 9 and 12, yeah, 9 is less than 12, so no swapping. 12 and 15, 12 and 15, 12 is less than 15, so 15 will be there here only. 15 and 22, 15 and 22, 22 will be there here. Then 22 and 18, 18 will come here and 22 will go here. Till there only comparison will happen. The 26 will be there only, guys. The 26 will be there only. No comparison is required for the 26 because it already bubble. Bubble has come here in the form of 26. Now another bubble also we got. Apart from this, we got 2 bubbles this time. 26 is the previous bubble and 22 is the latest bubble. 22 is the latest bubble. Now the swapping will happen in the next category now. How means like this. Okay, 22, 26, no comparison will be done. Okay, no comparison should be done. Now 2 and 3, no comparison required. 2, 3 will be like that only. 2, 3. Then 3 and 7, no comparison required. 7 and 8, I mean no swapping required, sorry. 2 and 3, because 2 is less than n means no swapping. 3 and 7, no swap. 7 and 8, no swapping. 8 and 5, 5 will come here. 5 will come here and 8 will come here. Okay, 8 and 4, 4 will come here and 8 will come here. 8 and 9, 8 will be there only, 9 will be there only. Okay, 9 and 12, there only. 15 and 18, there only. 15, 12 and 15, there only. 15 and 18, no need to swap. So the bubble has come here as 18 in the form of 18 and final elements are 22 and 26. Now 3 bubbles got created. That's why this algorithm is called as bubble sort algorithm. So now the comparison happens with the remaining elements, guys. The remaining elements comparison will happen. This is what is bubble sort algorithm. This is how it works. For this, we have to write the program. The concept looks very difficult, but the programming is very easy, guys. 2, 3. We write on here 2, 3. It will not swap because 2 is less than 3. 3 and 7. 3 is less than 7. No swapping. Swapping only happens before number is greater than, then only swapping happens. Now 7 and 5. 5 will come here. 7 will come here. Okay. Swapping will happen. Then 5 and 4, 7 and 4, sorry, 7 and 4. 4 is less than 7, so 4 will come here and 7 will come here. Then 7 and 8, it will not change anything. 8 and 9, it will not change anything. 9 and 12, nothing will be changed. 12 and 15, nothing will be changed. The biggest number will be 15 here. So newest bubble we have got is the 15. Along with the 15, we have the previous bubbles as the 18, 22, and 26 as the previous bubbles. Okay. So latest bubble is 15, guys. And the biggest number will go into the last. Okay. So like that, multiple bubbles are coming and they are staying to the right side of the array, let's say. Okay, these are our array elements. Let's assume that you are swapping. So now come back here and write down. Just see the comparison again. 2 and 3. Again 2 and 3. No changes required. 2 will be there here. 3 will be there here. 5 and 4. Swapping will be done. 4 will go here and 5 will come here. 5 and 7. No swapping required. 7 and 8. No swapping required. 8 and 9. No swapping required. 9 and 12, no swapping required. Okay, that's it, guys. Okay, latest bubble is 12. This swapping will not continue here. Previous bubbles will be coming here. That's it. Okay, just have to copy the previous bubbles here. Okay, 22 and 26. Now, latest bubble we got is 12. Okay, so sorting is happening. As you can clearly see that sorting process is happening because of this bubbling concept, right? By swapping and with the next number and all creating new bubbles, right? The swapping is automatically happening where the least numbers are coming to the left side and biggest numbers are going to the right side. Now here, 2, 3, 2, 3, guys. 2, 3, 2 will be there here. 3 will be there here. 3, 4, no swapping required. 4, 5, no swapping required. 5, 7, no swapping required. 7, 8, no swapping required. 8, 9, no swapping required. The previous already, we got the 12 as a bubble, guys. I didn't draw. Now the latest bubble is 9, guys. Okay, latest bubble is 9. So previous bubble are 12, 15, 18, 22, 26 are the previous bubbles. Okay. Now the latest bubble we got is as 9. Okay. Previous only we got the 12 as a bubble. Now latest bubble is 9 onwards. We got the bubbles. Okay. Previous bubbles are 12, then 15, then 18, then 22, then 26. Okay. Now run this code. Now just draw this thing, and now again do the swapping process. This swapping process is clear. You have to do it, guys. Okay. No matter what, you have to do it. Whether you clearly see that no more swapping is required, also you have to do. First 2 and 3. 2, 3 will be there. Then 4, 3 and 4 again 4 will be the biggest. 4 and 5 no swapping. 5 and 7 no swapping. And this time latest bubble is 7 and 8. 8 is the latest bubble. Okay. And remaining all are same. That is 9, 12 or the previous bubbles. You don't have to do any comparison here for the previous bubbles. 18, 22, 26. Okay. Now what happens here? The latest bubble is 8, guys. Okay. Similarly, the previous bubbles are this 9, 12, 15, 18, 20, 22, and then 26. Okay. Now again, we have to do the swapping. Until all the bubbles are created, everything should become a bubble. Then only we can stop, guys. Okay. So have to continue no matter what. 2, 3, same places. 4, 2, 3, 4, same. 4, 5, same position, no swapping. 5, 7, no swapping. Now latest bubble is 7, guys. Okay. Previous bubbles are 8, 9, 12, 15, 18, 22, 26 are the previous bubbles. 26 are the previous bubbles. So here, latest bubble we got here in this case is 7. Okay. The previous bubbles are 8, then we have 9, then we have 12, or all are the previous bubbles. Only swapping will happen. Non-bubbles only swapping will happen. Okay. For every iteration, swapping will happen only between the non-bubbles. Already, if the bubbles are created and they went to the right side, the largest numbers of this array, when they become bubbles and go to the right side, the remaining elements only swapping should happen. 2, 3. 2, 3, no swapping. 3, 4, 3 is less than 4, no swapping. 4 is less than 5, so no swapping. Latest bubble is 5, guys. Previous bubbles are 7, then 8, then 9, then 12, then 15, then 18, then 22. These are the previous bubbles. 26, the previous bubbles. Okay. Now, the latest bubble we have got is 5 here. Okay. 5, 7, 8, 9, then 9, 12, then 15, then 18, then 22, then 26. Okay, is also done. Now remaining all elements, the swapping will be done. Okay. Okay, write it down. In that 2, 3, 2 is less than 3, no swapping. 3 is less than 4, no swapping. So latest bubble is 4 now. Remaining previous bubbles are 5, 7, no swapping is required here, guys, because they are already converted as bubbles. 9, 12, 15, 18, 22, 26. Okay. Now latest bubble is 4, guys. Okay. Latest bubble is 4. We'll write the 4 here. And then we have 5 as the previous bubble, 7 as the previous bubble, 8 as the previous bubble, then 9 as the previous bubble, then 12 as the previous bubble, then 15 as the previous bubble, just 18 as the previous bubble, 22 as a previous bubble, and then finally 26 as the previous bubble. Only 2 elements are left out. So here we'll write the code. That is, 2, 3, no swapping is required between 2 and 3 because 2 is less than 3. The latest bubble is 3. Since only one element is there, you don't have to swap anymore. Okay. Only one element is who will you compare with? Already this is compared with. You see, bubble swapping is you cannot do swapping with the bubbles, guys. Okay. Once they're converted as bubble, here latestly 3 got converted as a bubble because 2 is less than 3. So latest bubble is 3. 3. The previous elements are 4, 5, 4. Just giving some space here so that we can draw it properly. 7, 7, and then use some space 8, then 9, then 12, then 15, then 18, then 22, then 26. This so latest bubble we got as 3. So these are all the previous bubbles. Now The rule here is you cannot compare the array elements with the bubbles. So only one element is there, remaining all bubbles. So swapping will stop here. This is the end of the swapping. How many times we are swapping? How many times we have to do this process of comparing the first element with the next element, the second element with the third element with the fourth element? How many iterations we have done this swapping? That you have to understand this. That's the reason I have explained till here. So for example, if you count the elements, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 means how many times swapping is done? First time, second time, third time, fourth time, fifth time, sixth time, seventh time, eighth time, ninth time, 10th time, 11th time. Here swapping has not happened. Here swapping has not happened because already converted to bubble, right? So if there are 12 elements, how many times swapping will be done? Till 11 times swapping we have to do. Okay. So swapping the first element with the second element with the third element with the fourth element with the fifth element with the sixth element with the seventh element, the eighth with the ninth with the tenth with the 11th with the 12th. Once a bubble comes here, then first with the second with the third with the fourth with the fifth with the sixth with the seventh with the eighth with the ninth with the 10th with the 11th. The next iteration, 2 bubbles. So first with the second with the third with the fourth with the fifth with the sixth with the seventh with the eighth with the ninth with the 10th. Here, like that, it will keep on going. How many times the swapping should happen in between? 11 times. 11 times we have to swap. Okay. If the size of this array is 12 means how many times the swapping should happen? How many times you have to plan the swapping process for each and every first element with the second with the third? That process of repeating, you have to do 11 times you have to do. Okay, 11 times. This is what will help you in, creating the logic, guys. Now let me switch to the required workspace. I think it has not switched. I thought of switching, but somehow it has not got switched. So this concept, let's try to understand. Meanwhile, it switches, right? We'll try to understand the concept here. So bubble sort is a simple sorting algorithm that repeatedly steps through the list. Okay, that repeatedly steps through the list, compares adjacent elements and swaps them if they are in the wrong order. The pass through the list is repeated until the list is sorted. Okay, bubble sort is a simple sorting algorithm that repeatedly steps through the list, compares adjacent elements and swap them if they are in the wrong order. The pass through the list is repeated until the list is sorted. So here is how the algorithm works. This statement you may not understand clearly, but with this example I have taken here, you got some idea about how the sorting is happening. That's the reason I gave that example before I read this particular text. Okay. So first step is start with the first element in the array, guys. Okay, start with the first element in the array. For example, first element in the array is 3 here, and with its adjacent element, okay, compare the current element, that first element, with the next element. If the current element is greater than the next element, swap them. Now move to the next pair. After swapping is done, move to the next pair. That is a first element with the second element is done, right? After swapping is happening or swapping has not happened also, second element with the third element, you have to continue this process. Okay, should be continued, guys. Okay, and repeat the steps 2 and 3 until the end of the array is reached. Okay, you see, we are swapping, right? 3 with the 2, 2 with the 9. Sorry, after 3, 2 got swapped here. 3, you see, 3, 12 are there, right? Sorry, what is this happening? Yeah, 3 and 12 were there. So in that 3 is no swapping happened. 12 and 2 got swapped. Okay, 2 came here, 12 went here. Then 12 and 9 came here, 12 went here. Like that, we have to keep on going, guys. Okay, so that's what they are saying here. Okay, move to the next pair of elements and repeat the steps 2 and 3 until the end of the array is reached. That so that the bubble is nothing but the highest element, largest element of all the elements in the array. So for swapping is being done, right, in that resultant thing, that item will go to the last, okay, as a bubble. After the first pass, the largest element will be the bubble to the end of the array. Repeat all these steps again. How many times we have to repeat this? In our example, if there are 12 elements in this array, we have to repeat this 11 times. This swapping process with the adjacent elements, we have to repeat 11 times. That's what it is saying. So that the sorting will happen. The main idea behind the bubble sort is that after each iteration, the largest unsorted element bubbles up to its correct position, that is the last position. Hence the name bubble sort. This process continues until the entire array is sorted. Okay. Bubble sort is a straightforward to implement, but not very efficient. Okay. It's very easy to implement, but not very efficient because, swapping 12 elements means 11 times you have to sort. That too, comparing with each and every iteration, you have to sort with adjacent elements until you reach the end of the elements by leaving the last element which is already converted as a bubble. You should not swap the bubble anymore. Okay, you don't have to do any comparison with the bubble anymore once it is went to the right side. Okay, so with practical demonstration, I am going to show you how to write a Java program to demonstrate bubble sort. Hope you understood the concept of the bubble sort. And here 12 elements are there, means 11 iterations of sorting of adjacent elements will happen to create 11 bubbles should be created. Okay, 11 bubbles, 1 2 3 4 12 elements means 11 bubbles should be created, means 11 times you have to keep on swapping to create the bubbles. Okay, so for that kind of thing, how to write the program, I'm going to show you guys. So here I'm going to create a new class, guys. Here I'm going to create a new class. I'll just name this class as bubble sort algorithm or something. I'll just name it. You can give a particular name. Bubble sort demo class. Okay, bubble sort class demo. Okay, just give some random name with main method you create. Click on finish. After you click on the finish, control plus plus so that you can see the code. I have to say control plus plus, guys. Control plus plus, control minus. Okay. Here, okay. Just give me a second. Okay. Here, guys, I'm going to write some code, guys. I'm going to write some code that is yeah, I'm going to create an integer array. Integer array AR is equal to, I'll write the element. Same element shall I write? So that we can see that 3, 12, 2, 9, 3, comma, 12, comma, 3, comma, 3, 12, sorry, 2, comma, 9. Same example I am taking, guys, whatever the example I took. 7, comma 8, 7, comma 8, 5, comma 4, 5, comma 4, then 15, comma 26, 26, comma 22, 22, comma 18. These are the elements, right? Total how many elements are there? 12 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I just want to bubble sort. Before performing any bubble sort, I would like to print this array, guys. I'll just write down system.out.println. I'll simply say before bubble sort. Before bubble sort, what is array elements? Okay, I'll simply say there is a predefined class in Java known as arrays class. Arrays dot to string of this integer array you have to select. The integer array is nothing but this AR. It will be printed. Before sorting what is array, you run this code and see the array elements will be printed like this. Okay. This is the easiest way to print the array elements instead of using some loops and all, right? You see, before bubble sort, these are the elements. Before bubble sort, 3, 2, 2, 9, 7, 8, 5, 4, 15, 26, 22, 18. Okay. After sorting, I would like to print the array again. Okay. After sorting the array, I would like to print the array again. So here, what I'm going to do here is, I'm going to create one method, guys. Okay. Public static void bubble sorting demo. Okay. Bubble sorting demo. Okay. Bubble sort or bubble sort demo or something. Okay. Demo is also fine. No problem. It's a method actually. You can give any name. That's okay. Here you have to pass the array elements that you want to bubble sort. For that you have to pass the array, guys. For that I'll give the integer array. Integer array ARR I'm giving. Here AR is there. I'm giving ARR. You can give AR also. Not a problem. But you can give a different name also. So this particular array elements will be passed to this array. And once this particular gets the array, right, first we have to find the size of the array. Here, why I'm finding the size, if the element size of the array is like 12, how many iterations we have to iterate? 11 times for this bubble sorting process. That's why we are finding the size. Int some n is equal to some n, number of elements. Okay, assume that n stands for number of elements for a while. ARR dot length. Okay, ARR dot length I'll say. Now for int I is equal to 0, because array index elements will start with a 0, right? So I is equal to 0. I less than n minus 1. Why I'm saying n minus 1? Because if there are 12 elements, how many times iteration should happen? 11 times. If there are 12 elements, iteration should only happen 11 times. So I is equal to 0, I less than n minus 1, I plus plus. I plus plus I'll write. And here I'll write the code. Okay. Here I'm going to write the code for int I is equal to 0, I less than n minus 1, I plus plus. Okay. Here I'm going to write the code. That is, I'm going to write the code like this. Int n is equal to ARR length for int I is equal to 0, I less than n minus 1, I plus plus. Here, after this is done, guys, after this is done, I'll write this many iterations we have to do. For every iteration, these are 11 iterations, guys. These are 11 iterations. In every iteration, we have to make sure that we are swapping the, we are comparing the first element with the second element, second with the third element. After swapping, second element with the third element. After swapping, third element with the fourth element. After swapping is done, fourth element with the fifth element. Like that, we have to do. This is another for loop. For the swapping of the individual elements, we have to do another for loop. How to do that swapping? To do that swapping, guys, okay, we have to write the code like this. For int j is equal to 0. In every iteration, again, we have to have one more iteration for swapping process to be done. J less than n minus I minus 1. So why I'm saying I minus 1 here, I can simply say n minus 1, right? Why I'm saying I minus 1? Because in every iteration, at the end of every iteration, one bubble will be created. That bubble should not be compared anymore. Out of the 12 elements, one bubble already got created. Remaining elements are how many? 11. Only 11 should be done. After the second iteration is done, 2 bubbles got created. Remaining elements only will be 10. So 10 times only the inner for loop will iterate. That's the reason to reduce the number of iterations of swapping should happen. Swapping process should happen only for 10 elements here. Here, initially, 11 elements should be. Initially, j is less than n minus I minus 1. In the first iteration, when the elements are like this, how many swapping process should contain? 3 will be 3 will be compared with 12, 1. Then this element will be compared with 1, 2. Then this element will be compared with this one after swapping is okay. 3 times, 4 times, then 5 times, 6 times, 7 times, 8 times, 9 times, 10 times, 11 times. So there are 12 elements, 11 times swapping is happening. So here n minus I minus 1, if you say, that is n is nothing but what? 12. 12 minus 0. Minus 1 means 11. J less than 11 means 0 to 11 means 0 to j less than 11 means up to j becomes 10. Okay. So swapping will continue like that, guys. Okay. J plus plus. 0 to 10 means 0 to 10 index means it's nothing but 11 elements are being 11 times the swapping is being done. Okay. In a one iteration, 11 times the swapping is being done, guys. Okay. J less than n minus I minus 1 is the important thing that you have to remember. This you can remember why, because here 12 elements are means 11 iterations, 11 times bubbles should be created. 11 times the bubbles have to be created. That's the reason in external for loop will create the bubbles. And for every bubble to be created, we have to compare the adjacent elements. Okay. How many adjacent elements will be there in the 12 elements? This is one couple. Okay. This swapping one another. Okay. This is another one. This is another one. This is another couple of numbers. This is another couple of elements. Numbers. Another couple. Like that, 11 couples will come for swapping. Okay. So here, the thing here is, that's what will happen, guys. So that's the reason this logic is going to work fine. Okay. This logic is going to work fine because of that reason. In the next iteration, we don't have total 12 elements, 11 couple swappings will happen here in the 12 elements. But here, when there are 11 elements remaining, one is already converted to bubble, only 10 swappings can be done, right? Only 10 swappings can be done. When there are 10 elements, 9 swappings can be done, 9 couple swappings can be done here. Okay, couple elements swapping can be done. Okay, then if there are 9 elements, 8, like that, that's the reason, guys, we are minusing I from the n. Okay, that's the reason. Now, write down something like this. If when we have to do the swapping, guys, when the first number is compared with the next number in the array, adjacent element in the array, next element in the array, and if the first number is greater than second element, then only we have to swap. That's the reason I'll write ARR of j, that is 0. ARR of j is nothing but 3. 3, if that 3 is greater than ARR of j plus 1, the next element is j plus 1. Here j is equal to 0. Here j 0 plus 1 means ARR of 1 will come. ARR of 0 is greater than ARR of 1. That means 3 is greater than 12. If that is so, then we have to swap. If this condition is satisfied, then only we have to swap. Otherwise, we should not do any swapping there. Okay, should not do any swapping. For swapping, you know the logic, right? Int temp is equal to 0, temp is int temp is equal to ARR of J. Okay, this one biggest number that I'm providing it temp, and then this logic you already know how to swap the two numbers which are indifferent. ARR of J is equal to ARR of J plus 1. Okay, because that's what we are doing for swapping, because if in case this AR of J is the first element is greater than second element, this is how it will be done. Okay. Then finally AR of J plus 1 is equal to 10. The swapping will be done. Only when the first number is greater than the next adjacent number, then swapping will be done. Otherwise, swapping will not be done. Swapping will be done only in this case. Otherwise, swapping will not be done, guys. Okay. So next, yeah, this is good. And here we are doing for the integer array, and all the process is done. Finally, after the external for loop is completed here, okay, once you come out of the external for loop, then you return ARR, which is nothing but the integer array as a return type. So here pass the integer array as a return type. ARR is nothing but integer array type. Okay. So if you call this method, call this bubble sort demo method, and when you pass this array, this original array, okay, it will sort the things, sort the elements in this array. Using the bubble sort algorithm, it will sort the elements in the array. After the sorting is done, it will return the resultant array. The return type of this bubble sort is integer array. I'll simply say int integer array R array. RAR means resultant array, let's say. Okay, resultant array. Now system.out.println, after bubble sort colon plus arrays dot to string of, I'll print out that RAR. Whatever the resultant array that came, that I'm going to print it out. I'm going to show you practically, guys. I'm going to show you practically how this happens now. With this example, I'll show you what the sorting is happening. So you have to understand this logic, guys. How many iterations, how many bubbles I have to create? 11 bubbles. So that's the reason I have written 0 to n minus 1. That is 12 minus 1 is 11. That means 0 to 10 becomes 11. 11 iterations external file loop will iterate, because we need to create how many bubbles here? If there are 12 elements, we have to create 11 bubbles. Okay, at the end, we should get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. For every iteration, you are getting one bubble, guys. Okay, for every iteration, you are getting a new bubble. You are getting a new bubble for every iteration. Okay, so 11 iterations. That's why we have written the logic like that. Here, what we are doing, as part of creating every bubble, to create every bubble, we have to compare the first element with the second. After swapping is done, second with the third. After swapping, third with the fourth. After swapping, fourth with the fifth. That we have to do in every iteration. Okay. For creating the bubble and to moving that bubble is nothing but the largest elements in the element that has to be swapped to the right side completely. And the final one will become the bubble. Okay. For that to happen, I have written the, let's assume that I is equal to 0 here. And these iterations will happen where n minus I minus 1. That means how many swappings should happen? If there are 12 elements, how many swappings should happen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 swapping should happen if there are 12 elements. Okay. In the first iteration, as part of creating a bubble, 11 swapping should happen. That's the reason n minus I minus 1, 0 to. N means what? N is nothing but 12. 12 minus I is 0 minus 1. That is j less than 11 means up to 10, 0 to 10. That is 11. That's correct. In the next iteration, one bubble already created. Okay, after this complete things are done, swapping and everything is done. Here I will become 1. When I becomes 1, j is equal to 0 again. J is equal to j less than n minus I. That is, this time I is 1. N is 12 minus 1 minus 1. 12 minus 2 is 10. 0 to 9. 0 to 9. J should be less than 10 means 0 to 9 is 10 elements. Here, how many swapping should happen? Already one bubble got created. Only 10 swappings. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 swapping. That's why this is the logic we have written. Minus I minus 1 we'll say. That's the reason. Okay. The next iteration, 2 bubbles already got created. So I will become 2. J is equal to 0. J less than n minus 2 minus 1. That is 12 minus 12 minus 2 minus 1, that is, it will come to 9, right? Something like that, okay? Yeah. So I is equal to 0, I is equal to 1, I is equal to 2 minus 1, that is minus 2 minus 1 means minus 3. 12 minus 3 is 9. 0 to 8, that is 9 times. Here 9 swapping should happen. 1 swapping, second swapping, third swapping, fourth, fifth, sixth, seventh, eighth, 9 swappings. Okay. Now 3 bubbles got created. In remaining elements only bubbles should happen. When I will become 4, sorry, I becomes 3. 3 minus 3 minus 1 minus 4, that is 12 minus 4, that is 8. 0 to 7, 8 elements. Here 8 swappings will happen. 1, 2, 3, 4, 5, 6, 7, 8 swappings. Okay, to create the bubbles. Then I becomes 5 minus 6, right? Minus 6. 6 times 0 to 5, that whatever it is. Okay, you keep on going, guys, until all the things are done. This is how the logic is written, guys. Now, in every iteration in the inner for loop, we are swapping the elements if the adjacent elements, when you are comparing these two couples, right? If this couple is less than the other couple, then no swapping. If this particular couple is greater than another couple, swapping will happen. Okay, that's what we are doing. And run the code and see whether we are getting the sorted array or not in the output. Okay, after running, you should get the sorted array in the output. So before swapping, before bubble sort, you see 3, 12, 2, 9, 7, 8, 5, 4, 15, 26, 22, 18 were there. After bubble sort, 2, 3, 4, 5, 7, 8, 9, 12, 15, 18, 22, 26, properly sorted. Ascending to descending is there. Okay, ascending to lowest number to the biggest, largest number is there. That means sorting is perfectly happened. With the help of bubble sort, we were able to sort the elements in the array properly. This is the logic behind that, guys. Hope you got the idea about bubble sort. Now you can, take the screenshot of this code, guys. You can take the screenshot of this main method now. Once you have taken the screenshot, let me scroll down here so that you can take the screenshot of this code, this method. This is very important. Logic is only here only, okay? If you understand this logic, you can do anything. Previous one was nothing much, okay? So take the screenshot of this logic using which you can perform bubble sort. You can implement the bubble sort algorithm. So hope, guys, you have taken the screenshot and hope that you got the answer for this question with practical demonstration. I tried my level best to make the answer for this particular question in as easy as possible. So that's all for this session. Thank you. Bye-bye.